Good morning, good afternoon, good evening. This is another one of my first podcast, I would say. This one I'll be talking about a guide to developing and delivering effective IT. So let's start. Internet security protocols are essential for ensuring the confidentiality, integrity, and authenticity of data transmitted over networks. Below is an example of the requested protocols along with examples, troubleshooting tips, and testing methods. Number 1, SSL, which stands for Secure Socket Layer. SSL is a cryptographic protocol designed to provide secure communication over a network. It encrypts data between a client, for example, a browser, and a server, example, a website, ensuring that sensitive information like passwords and credit card numbers cannot be intercepted. I'll provide an example. When you visit a website with https / in the URL, SSL or its successor TLS is being used to encrypt the connection. So you will look at the site, and as long as it has HTTPS at the end, it should be secure. If you don't see that, then you have to question that site. Troubleshooting. If SSL fails, check for expired or misconfigured SSL certificates on the server. Ensure that the browser supports the required SSL TLS version. You can test it. Use a tool like SSL Labs, SSL test to analyze the SSL configuration of a website. So you can check for vulnerabilities like outdated SSL version, for example, SSL version 3 or weak ciphers. The link has been provided, but anyways, I'm going to read it out loud. It's www.sslabs.com/SSL test /. Moving on, number 2. S-HTTP. That stands for Secure Hypertext Transfer Protocol. SHTTP is an alternative to HTTPS that provides encryption for individual messages rather than the entire communication session. It is less common used today as HTTPS. SSL, TLS has become the standard. Example of S-HTTP could be used to encrypt specific email messages or web transactions. Troubleshooting. You have to ensure that client and server both supports S-HTTP. Verify that the encryption keys are correctly configured. Testing. Use network monitoring tools to inspect whether individual HTTP messages are encrypted. Test compatibility with specific applications that support SHTTP. Here are several tools for what I just said. For example, you can use Wireshark. Wireshark is a gold standard for network protocol analysis. The way it works, Wireshark captures network packets and allows you to dissect them. You can filter for HTTP traffic using HTTP or TCP.port == 80 or HTTPS traffic TLS, SSL, or TCP.port == 443. Inspecting encryption. For HTTPS, Wireshark will show you the TLS handshake, you'll see the client hello, server hello, certificate, and other records. If the connection is properly encrypted, you won't be able to see the actual HTTP request and response data in plain text. Instead, you'll see encrypted application data. Remember, this is while you're using Wireshark. If you can see the HTTP content in plain text, something is wrong, indicating the connection isn't encrypted. Configuration. Wireshark needs to be installed on a machine that can see the network traffic. This might mean running it on the client machine, a network tap, or a mirrored port on a switch. That could be a Cisco switch. Decryption. That's advanced. Wireshark can decrypt HTTPS traffic if you have access to the server's private key, which in reality you shouldn't unless you are the server administrator and have explicit permission for testing. You can also configure it to use pre-master secrets capture during the SSL TLS handshake. Less common but possible with some client-server configurations. This allows you to see the decrypted HTTP content, which is helpful for debugging. Use this decryption functionality ethically and with appropriate authorization. The next tool, TCP dump, a command line packet analyzer. How it works. Similar to Wireshark, but command line based. Captures network packets and allows you to filter and save them for later analysis. Inspecting encryption. You would filter the port 443 HTTPS using TCP dump -I, the name of the interface, space port, that's space 443. The output will show TCP packets without decryption. You'll see encrypted data. So it will show you the packets without decryption, but you'll see the encrypted data for HTTPS. If you see HTTP headers and content in plain text, the connection is not encrypted. Advantages. Good for running on headless servers. This is for the TCP dump tool. Or when you need to capture data without a GUI and can be scripted. So TCP dump, you can encrypt it on the command line as well. Disadvantages. Less user-friendly than Wireshark. Fiddler. It's for Windows. A web debugging proxy. How it works. Fiddler sits between your browser and the web server, intercepting all HTTPS traffic. Inspecting encryption. Fiddler automatically decrypts HTTPS traffic after you configure it to trust its self-signed certificate. This allows you to inspect HTTP requests and responses in plain text. If you can't see the decrypted traffic, it could indicate a problem with Fiddler's configuration, or that the server is using a newer TLS version that Fiddler doesn't support. It's very less likely these days for that to happen. The advantages of using Fiddler. Easy to use for web browser traffic. Provides a nice GUI for inspecting HTTPS messages. The disadvantages. Primarily for web browser traffic, may not be suitable for analyzing traffic from non-browser applications. Browser developer tools: Chrome Dev Tools, Firefox Developer Tools. How they work: built in to modern browsers, the Network tab shows you all the HTTP requests made by the browser. Inspecting encryption: you'll see a lock icon next to HTTPS request, indicating they are encrypted. You can click on a request to see details, including the TLS version and cipher suite used. If there's no lock icon, the connection isn't encrypted, or the browser is indicating a security issue. Advantages of browser developer tools: very convenient for analyzing web application traffic. Disadvantages: limited to browser traffic. MITM proxy, which for those of you that don't know what that means, is man in the middle proxy, a free and open source interactive HTTPS proxy. How it works: it intercepts, inspects, modifies, and replays web traffic such as HTTP/1, HTTP/2, HTTP/3, WebSockets, or any other SSL TLS protected protocol. Inspecting encryption can be used as a man-in-the-middle proxy to decrypt HTTPS traffic and inspect the HTTP request and responses in plain text. Advantages: scriptable using Python, supports HTTP2 and WebSockets. Disadvantages: requires more technical knowledge to set up and use effectively. And this is the end of part 1. Please stand by for part 2. Thank you.